Alright friends, welcome back. In this video I'd like to go ahead and take a second day for section 1.1 from your textbook. In the last video for day 1, we basically went through and talked about graphs of equations. We talked about how to use the calculator to pull up these nice tables of values for the equations that we want to plot. We took a look at intercepts of the graph, and then we also took a look at algebraically how you can prove that certain graphs or certain equations have certain symmetries when you go to plot them. In this video I want to go ahead and move on in the same set of notes here really quickly and pick up right here where it talks about how we can be plugging things into the calculator and how we can actually go ahead and find your x and y intercepts in the calculator. So I just want to go ahead and demonstrate that by graphing this equation right here. So keep in mind that the calculator is only going to be able to graph equations that are set up in this way, right? So only equations that look like y equals this calculator is going to be able to graph for you. So if I go to the calculator real quick, then that's going to be an interface that looks like this. This is on the TI-84 Plus. Again, if you're using a different graphic calculator like a Casio, or if you're online using a graphing utility like Desmos or something like that, which we'll actually take a look at later in the video, that's going to be something that it's going to be a little bit of a different interface. You're going to want to do some different things for those. But I'm going to go ahead and punch in the y equals button up here in the top left-hand corner, and this pulls up all of these different y equals that I can go ahead and graph. And so our function here looks like 3x cubed minus 1, and so we're just going to go ahead and type that in. So 3x to the power of 3, and then minus 1. Okay, just take a quick step back and make sure that we have typed in something that looks exactly like what's on our paper, and that looks pretty good to me. And what I'm going to go ahead and do is make sure that I'm graphing this in the standard viewing window. And so if I was doing other examples and I was zooming in or zooming out, I just want to take a look at the standard viewing window here. Up here in the top middle is the zoom button. And then for some reason, I've never understood why, but the standard viewing window is all the way down here on number 6. This is just your standard viewing window. If you press enter there, you could also press the number 6 key in order to pull that up. The calculator will go ahead and graph this function for you. And so we have something that looks a little bit like this, right? What we want to do here is we want to go ahead and be able to find what its x and y intercepts are only using the calculator, okay? And so what I'll go ahead and recommend that you guys do is press this sequence of buttons here really quickly, right? We're going to go to the calculator and we're going to press second, and then after that we're going to press the trace button, okay? And what does that do for us? So if we go back to the calculator, if I press the second button and then traces up here at the top, you'll notice that what we're about to pull up is something that the calculator is going to call the calculate menu. And what we want to do is we want to arrow down to the second option, which says 0, because algebraically speaking, a 0 corresponds to, graphically speaking, what we would refer to as an x-intercept, okay? So if I go ahead and press enter here, then it's going to go ahead and ask me for a couple of different options. So when it's going to ask me for a left bound, what I want to do is I want to go somewhere to the left of where my graph crosses the x-axis. And so as long as my cursor is somewhere to the left of where that crosses the x-axis, another way to say that is somewhere below the x-axis, I could just go ahead and press enter here to lock that in, and you notice that it puts a little bit of a marker there for me where my cursor was. Now it's going to ask me for a right bound, and I'm just going to use my right arrow buttons to arrow somewhere to the right of where we cross the x-axis, or in other words, somewhere above the x-axis, and then I'm going to press enter again, and it's going to put a marker there. And so what I'm basically doing is I'm creating this little region, this little strip right here that's going to contain the region where I cross the x-axis. And I don't know why it does this as the next part. It asks if you want to maybe take a guess. We don't want to make a guess. We're just going to press enter if it says guess there. And then it's going to do all the calculations for us, and it's going to put the cursor right where my graph crosses the x-axis, and it's going to give you the coordinates for that down at the bottom there. So here it turns out to be a little bit of a decimal as my x-coordinate with 0 as the y-coordinate, but keep in mind that an x-intercept is always going to have 0 as its y-coordinate. So we know we got the answer right here. So just kind of going back to the calculator here real quick, or sorry, back to the notes, I should say, not the calculator. What we want to do is press second trace, and then we want that second option, which says 0. And then we're going to go ahead and do that process of going to the left and to the right of our x-intercept and then creating that strip around it, pressing enter, and it's going to give us that automatically. To find the y-intercept, we can go ahead and press second again and go back to that calculate menu by pressing second trace. But this time I want you to go ahead and choose the option that was in number 1, and that's actually going to say value. Because remember, for your x-intercept, that was a point that looks like some x-coordinate with 0 as its y-coordinate. And for the y-intercept, that's a point that looks like 0 for its x-coordinate and some number y as its y-coordinate. So what I'm about to do whenever I pull up value is I'm going to punch in a value of 0, and it's going to automatically tell me where my y-intercept would be. So if I go back to my calculator real quick, I'm going to go back to second trace, And then the first option, again, is number 1, where we want to type in an x value. And, of course, where my y-intercept is, that's just an x value of 0. So press Enter, and it's automatically going to put my cursor right there at the y-intercept for me. So that's going to be a point with coordinates 0, 1 here. So you can use the calculator and these little fancy tricks to go ahead and figure out what your x and y intercepts are. That's pretty handy, okay? So if you guys always have any questions about the calculator, always feel free to let me know. But for the rest of the video, I want to hone in on a very special type of equation, and that is your equation of circles, okay? You'll notice here that the standard equation of circles, this is something that you guys should have first taken a look at in your geometry class way back when, but it's something that looks like this. We use Pythagorean theorem to derive this equation, and I'm not going to dive too deeply into that, but what I want to point your direction towards is the fact that whenever you look at the equation of a circle, you need to pay particularly close attention to 3 key pieces of information here. And what those informations are what is playing the role of h, what is playing the role of k, and then on the other side of the equal sign, what is playing the role of r. If you're able to point out those values, then playing the role of r, that's just going to be the radius of the circle, and h and k turn out to be the coordinates of the center of your circle. If you have the center and you have the radius, you have everything you need to draw a complete picture of your circle, and so that's why that's the only information that we're looking out for whenever we do the standard equation. Now, one annoying thing is that keep in mind the calculator can only handle equations that, of course, look like y equals. We said that before. And if you look at the standard equation of a circle, that is not something that looks like y equals, does it? Okay? But lucky for us, there are other graphing utilities separate from our calculators that we can use, and a really easy one to use would be Desmos.com. So if I go ahead and pull up the internet here really quickly, I'm going to go ahead and show you this website. Okay? So that's desmos.com. And if I pull that up, it's a free website. There's nothing to pay for. There's nothing to download. In the middle here, if I just press Graphing Calculator, then what this does is it pulls up a nice, easy-to-use graphing calculator for our graphing purposes. And so we're going to go ahead and use that as we go through a couple of examples today. So say, for example, we're doing this first one, right? It says find the center and the radius of a circle with this equation right here, okay? Well, that is something that I could just take straight to Desmos and type that in, okay? So let's go ahead and actually perform that here, right? So I believe this said x minus 4 squared plus y squared is equal to 16. So if I type that in, x minus 4 squared, again, I'm just using the computer's keyboard to go ahead and type this in. That's plus y squared, and that is equal to 16. If I press enter on that, you'll notice that I end up with this nice circle. And if I'm being asked where the center and the radius is, well, the center, of course, would look like be at a point with these coordinates. I just go from the origin to the right 4. So that would just be a point with coordinates 4, 0. Okay, if I'm looking for the radius, remember the definition of radius is that distance between the center of the circle and the circle's edge. So if I count over from the center of the circle, I would just have a distance of 4 units to get from the center straight back to the origin, and that would be the radius. So I know that my radius here would, of course, be 4, and that is an easy way to go ahead and check that your answers for what we're about to do are correct. Okay, because what we're about to do is this. We're going to go ahead and try to match this up to the general equation from a circle that we just took a look at, right? So that up above was something that looked like, of course, x minus the number h squared plus y minus the number k squared is equal to r squared, okay? If we match up to this form, then remember that playing the role of h is whatever number is sitting after that x minus in the equation. Well, for us, that is just simply going to be the number 4 here. So if I start to write down my center, I automatically now know its x-coordinate. It's going to be that h value, which of course is 4, and its y value is going to be whatever is sitting after the y minus, okay? And here that is going to be k, and if you look at our example, it doesn't look like we're taking y and subtracting off anything, but remember that we could always rewrite that as y minus 0 squared. And so playing the role of k here would, of course, be 0. And so voila, automatically we already have the coordinates of our center. And then as far as the radius is concerned, I want us to be a little bit careful in this case because you'll notice that sitting in the seat of r squared in the general form, for us in this example, is the number 16. Well, all that means is that if I were to go ahead and take r squared and 16, I might just go ahead and set up myself a little quick mini equation there and then figure out what r is from here. Well, if the radius squared is equal to 16, then that means that the radius is whatever number that I would square to make 16. Or in other words, if you wanted to solve this little mini equation, you would just have to take a positive square root of both sides. Positive because, of course, lengths can never be negative. and we would see here that r is equal to the square root of 16, which of course is going to be 4. So a very easy way to go through and figure out what the center and the radius of your circle are just by looking at the equation and matching up the forms and figuring out what's playing the role of what. So you can see there that there's really not a lot of algebra involved there. Maybe another example here, maybe again matching this up to the general form. What I want you to notice here is that playing the role of h, we're going to need to be a little bit careful because again, playing the role of h is the number that's sitting after the minus. And if you ever have a plus here, then remember we can always write a plus as a double negative. And so if we write it in this way, then what's sitting after the x minus is apparently the number -3. So if I were to take a look at my center here, I know that the x-coordinate would have to be -3. So an easy way to remember that, folks, is just to remember that if you ever see a plus here, then that's going to correspond to the opposite sign whenever you write that coordinate down. And then continuing with the general form, we would pick up with a plus y minus k squared. And again, what's sitting after the y minus is whatever k is. Here that is, of course, a 5 for us, so we're going to go ahead and say that my center has coordinates of -3 and 5. And then in my general form, remember that we pick up with a equals r squared. And again, we're just going to have to be a little bit careful because sitting in r squared seat is the number 12. And so if we wanted to, we can go ahead and set up that little mini equation for ourselves. R squared is equal to 12. And then we can go ahead and solve that little mini equation for whatever the radius is. So I would just simply take a positive square root of both sides to signify that lengths can never be negative. And so r here would just simply be the square root of 12, and that is a radical that we can, of course, simplify. So this is what we did towards the beginning of the year, where we took 12 and we found the largest perfect square that goes into 12. That, of course, I believe would be 4. So if I'm taking the square root of 12, that means I'm taking the square root of 4 times the square root of 3, and so r is simply just going to be here the square root of 4, which is 2, times the square root of 3, which I can't really evaluate really nicely here. So my center and my radius are both accounted for. And so again, if I ever give you the equation of a circle, it's just a matter of matching up forms and seeing what's playing the role of what. You can very easily get your center and your radius that way, okay? What I want to do now is I want to go the other way around. So maybe if I give you the center and the radius, can you come up with the equation of a circle? Okay, well, it'll be the same exact thing here, right? So write the standard equation. Here I'm giving you the center. That is the points -1 and 3, the coordinate points there. So that is going to be what's playing the role of h and k, of course, and then they give us the radius here, so that's pretty nice. So starting over with the general form here, that was x minus h squared plus y minus k squared is equal to r squared. We're just going to match up forms and plug in our stuff. So playing the role of h here we said was -1. Playing the role of k here was +3. And then, of course, playing the role of r here was that 3 square root of 5. So if I plug in all my stuff, that was x minus the h value, which was -1, squared, plus y minus the k value, which was +3, squared, and that is equal to that radius squared, okay? So let's go ahead and do some cleaning up here. So in my x group up there, I have x minus -1. We can, of course, change that to x plus 1 squared. And then y minus 3 squared is not going to be something that can continue to simplify. And then we have 3 times the square root of 5 squared. If you really wanted to do this in the calculator, you could, but it's super easy to do mentally because all you have to think about is, again, we talked about this when we ever did exponent rules, but everything inside that set of parentheses is going to get raised to the power of 2. So 3 to the power of 2 is 9. Square root of 5 to the power of 2, those undo each other and just leave you with a 5. So really it's just 9 times 5, or in other words, just simply 45. Okay? If doing it mentally is something that you are not very comfortable with, then you do have my permission to go ahead and use the calculator on that. But again, that would require wasting time to punch in the buttons. So if you can get used to doing it mentally, that's going to be very much preferable. Okay? And again, that's something that you can graph in Desmos if you like. Here in this next example, I don't give you the radius. Instead, what I give you is the center point, which is something that you need. Remember, we said that was h and k. But instead, what I do is I give you something that I'm calling the solution point. So if I draw a picture of a quick circle here, folks, what I'm talking about here is if I have a circle and I give you the center, again, that's the coordinates hk, h and k, what I'm telling you here is a solution point is just going to be a point with coordinates x, y, and that point would have a location on the edge of the circle, okay? So x and y here would be what I would consider to be a solution point on this circle. If it sits on the circle, it's a solution point for that circle, okay? And so keep in mind that that's not really the information that I'm looking for. The information that I'm looking for is the radius, which again is that length from the center straight to the circle's edge. That might be what we call r here. Well, If I want to go ahead and figure out what that distance is, then that might be something that I need to bust out our old-fashioned distance formula to go ahead and figure out here, okay? And that's exactly what I want to do to start this problem off, is I want to go ahead and calculate the distance between the center point and the solution point that's sitting on the edge of the circle, okay? So let's go ahead and do that, right? So distance formula, if you forgot, that was d for distance is equal to the square root. Or matter of fact, instead of saying d for distance, since this just corresponds to the radius, I'll say r for radius. And that is just going to be equal to the difference of my x-coordinates squared plus the difference of my y-coordinates squared. So my two x-coordinates here are 2 and 4. If I were to go ahead and subtract them, maybe try to avoid dealing with a negative there, say 4 minus 2, and square that, I'm going to go ahead and add that to the same operations, but for my y-coordinates here. So that is 1/2 and 1. Again, maybe set this up to avoid dealing with a negative. All right? So we're just doing the distance formula here really quickly. So 4 minus 2 is 2. Square that, you get 4. So we'll say the square root of 4 plus 1 minus 1/2. If you start with one apple and you take away half of the apple, then you're left with the other half of the apple. So 1 minus 1/2 is just 1/2. And then if you were to square that, you square the 1 on top, you square the 2 on bottom, that would give you 1/4. Or again, if you're uncomfortable with that, feel free to use the calculator. But it's at this point that we have to go through and find a common denominator. I'm not going to take you through that work because it would just be, more work that we've already demonstrated in previous videos here. What I will tell you is that when you combine 4 plus 1/4 into 1, that would be the fraction 17/4. Now, it would be at this point that in the past, we would want to go through and rationalize this denominator, but I'm actually going to recommend that you keep it in this form, because remember that whenever you skip to your standard form of a circle, which we'll go ahead and start to write right now, this was x minus the h value, the x-coordinate of your center, and here that was a 2. We'll square that. Plus y minus k, playing the role of k, of course, is a 1/2 from before. That's going to be equal to r squared in the formula, and if r is the square root of something, and we're just going to square it in the formula, then remember that square rooting and squaring, those are inverse operations, and it just leaves you with what was under the root. So simply that would just be 17/4 here, and that would complete the problem, okay? And this would be a very, very good one that you would want to go ahead and use Desmos to check. So if I go back to Desmos real quick, and I delete those out of here, I just want to go ahead and type in the equation that I said we would have, and then check to see if that matches the description that I was given before. So if I just go through here and begin to type in my final answer there, got to be a little bit careful about how you type this into Desmos because it gets picky on a couple of those different things. We said that this is equal to 17/4. If I press enter here, it's going to give me this circle right here. What we were wanting, of course, is for this to be the circle that has a center at 2 1/2. So let's plot that point and see that that checks out. So a point with coordinates 2 and 1/2 would sit right there. That looks like the center to me. And then we also wanted the solution point of 4 1 to sit on the circle's edge. And of course, it looks like that, of course, happens right there. So we know we have the exact right answer solution to our problem here, okay? So sometimes I'm not going to straight up hand you the center and the radius like I did in number 7. Maybe I hand you the means to find that information on your own. And then in number 9, this is exactly like that. So instead of handing you either the center or the radius, here I'm just going to give you the endpoints of a diameter. Okay, so maybe recalling back to geometry class, what is a diameter? If you have a circle, that is simply just the straight line distance passing through the center, okay? So the diameter here would just simply be that straight line distance passing through the center of a circle just like that. What I'm telling you is I'm giving you the endpoints of this diameter. So what I'm giving you here in this problem are the two ends of that diameter. Here I'm telling you that that's going to be a point with coordinates 0, 0, and then a point with coordinates 6, 8. Okay, so let's go ahead and plot those real quick. So I have 0, 0 here, and then 6, 8 would, of course, be right here. And if you think with me here, we would need to go ahead and find what the center of the circle is, and then we would need to go ahead and find the radius of the circle here as well. So since I gave you the grid, it's actually super easy to find using the grid. If you didn't have a grid, this would be something that you would have to use some of the formulas we've talked about in the past for, right? So you can see here that because I want the midpoint between my two endpoints, then that might be something that I have to bust out my midpoint formula for. So I'll go ahead and say here that the center is going to be my midpoint of the endpoints of my diameter. So let's go ahead and bust out that formula again, right? So that was x the first, y the first, x the second, y the second. We want to go ahead and perform a quick average of my x and then a quick average of y. Okay? So for us, that would look like my two x coordinates are simply just 0 and 6. We would average those and get a 3. And then we would average my y coordinates from up above and get a quick 4. So if I plot that point with coordinates 3, 4, which would look like right here, then that looks, it actually kind of looks a little bit off. So maybe I made a mistake from before? Ah, yes. I plotted this point incorrectly. Check that out. I plotted the point 6.6. It should have been the point 6.8. So that actually should live right up there, and that looks a lot better, right? So there we go. And we can go ahead and approximate the rest of this circle by just kind of doing a rough sketch. It doesn't have to be perfect, and I have ink to shape on, so hopefully it's going to follow suit there, or actually it's not going to do anything. Okay, well, that's not too bad. All right, so my center is that. It's a point with coordinates 3, 4, and just remember that whenever we skip to later doing the general equation, this corresponds to those coordinates of h and k that we need to put into our equation later bit on, okay? Now we need the radius, and of course, now that we have the center, we know the coordinates of that, we just need to go ahead and figure out what the distance from one of my endpoints is to that center, and the reason that I might go ahead and pick the point 0, 0 is because, you know, when you plug 0 in, things get nice. And so we'll go ahead and find our radius by doing a quick distance formula here. So for radius, we want to go ahead and calculate a distance, and that'll be using the distance formula from a previous set of notes. So again, that was the difference of your x coordinates squared plus the difference of your y coordinates squared added together, and then all underneath a big square root, okay? So let's actually go ahead and go through and perform that. So we're going to do the distance between the points with coordinates 0, 0 and also 3, 4, okay? So 0, 0 is the origin, of course, and then 3, 4, that is the center. If we find the difference, distance between those, we're going to be finding our radius here. So let's actually go through and perform that. So 3 minus 0 squared plus 4 minus 0 squared, okay? Well, 3 minus 0, 4 minus 0, these are just 3 and 4 respectively. And if you square those numbers, you get 9 and 16. So 9 plus 16, of course, is going to be 25. And I know that that's going to be equal to 5, but again, I'm going to encourage you to leave it just like that because, again, we're going to be plugging that in for r in our equation, and we're just going to end up squaring that quantity anyway, and that's going to turn into a 25. So my final answer here is going to be x minus h, which is 3, squared, plus y minus k, which is 4, squared, and that is going to be equal to my radius squared. Well, that's the square root of 25 squared, or in other words, just simply 25. So there's really no need to evaluate that square root of 25, although we all know that it's 5, because we're just going to end up squaring that quantity anyway to get our final answer here. So just a little bit of a discussion about the equations of circles. I hopefully that makes sense for you here. If not, then please be sure to let me know. Make sure to use those graphing utilities, whether it be the calculator or Desmos, and make sure that you're checking your answers. Build some confidence with this material. And if you guys have any questions, as always, feel free to let me know. So thank you very much for your attention. I will speak to you guys in the next one.